All right, here we go. FRQ B. Let's do it. So FRQ B, again, the second FRQ on the AP exam will always be calculator active, so keep that in mind. Especially, you'll see this intense function here. Calculator's going to make it easy to work with that. So here we go. Traffic flow is defined as the rate at which cars pass through an intersection, measured in cars per minute. The traffic flow at a particular intersection is modeled by the function f, defined by, so this is a rate. Really important to note that. Has units. What units? Has units of cars per minute. All right, good to interpret that prompt before we start answering questions. Then I see where f of t is measured in cars per minute. Okay, it's a rate, and t is measured in minutes. Let's go to part A. To the nearest whole number, how many cars pass through the intersection over the 30-minute period? Well, the 30-minute period here I see is 0 to 30, so nothing strange there. So if I'm looking for how many cars, and I have a rate, and I'm looking for a quantity, I know I go from a rate to a quantity by taking the integral. So let's write an integral, and I'm going to take the integral of f of t dt, and then my limits, 30-minute period, 0, 30, f of t dt. I'm going to solve for what that is. Again, calculator question, got to use your calculator. Here we go. 82 plus 4 sine of x divided by 2. Great. Again, we can just use x here instead of the variable t. The calculator doesn't really know the difference right now. So, second quit, back to the home screen. We can do math, 9 for my integral, y1, comma x, comma 0, comma 30. Before I go, check, make sure I'm in radians. Radians. Hit enter. And there we go. There's my answer. So I'm going to type that in just as I have here. 2474.078. But then it said to the nearest whole number. So I'm going to, when I write my answer, I'm going to just round that to the nearest whole number. So 2,474 cars pass through the intersection over the 30-minute period. Okay, got the first part. Let's go to part B. Is traffic flow increasing or decreasing at t equals 7? Give a reason for your answer. Is traffic flow increasing? I know traffic flow is f of t. So is this traffic flow increasing? Well, I know something will be increasing if its derivative is positive. So f prime of t, positive for increasing, f prime of t, negative for decreasing. It's fine to use symbols in the annotations, but don't use symbols in your answer. So let's find f prime of t at 7. So f prime of 7. I could try doing the chain rule here, but you have your calculator. Use your calculator. So math 8. I'm using math 8 because I'm looking for the derivative of that function. So here we go. I'm going to use y1. I have the function here. So math 8, y1, comma x, comma 7. And I get f prime of 7 equals negative 1.873. Negative 1.873. So now I need to answer the question and give a reason. Not enough to just write this, I need to put it in context. The traffic flow is decreasing at t equals 7 because f prime of 7 is less than 0. You could also say f prime of 7 is negative. Either way, that's how you get 100% on part B. All right, let's think about part C now. What is the average value of the traffic flow? Average value of the traffic flow over the time interval 10 to 15. We know average value, thinking in my head, is 1 over b minus a times the integral a to b f of x dx. So I want the average value of the traffic flow. So if I apply that, this will be 1 over my intervals 10 to 15, 15 minus 10, integral from 10, 15, f of t dt, and then this would become 1 over 5. Again, this integral, you can solve it with your calculator. Use your calculator. Use the technology available to you. Again, y1 is the function. I'm going to do math, math 9 to get fn int, y1, comma x, comma 10, comma 15, enter. I get 409.496, 409.496, and then don't forget to divide by 5. So if I divide by 5, I get 81.8999. So I'm going to do 81.900 just to round 900. I just need to indicate units of measure. Well, f of t was a rate, and so I found the integral of that, so that gets me to a quantity, so I'm talking about cars, but then the units here were minutes, so this would be cars per minute. If I think about average value of traffic flow, it should still be the units of traffic flow, which I see should be cars per minute. So we're good with our answer here. Don't miss indicating units of measure. Easy point, thinking through that stuff that we've done before. So then I get to part D. I'm looking for the average rate of change of the traffic flow. We know the average rate of change formula is f of b minus f of a over b minus a. So here's my interval. Very similar question, slightly different. I'm going to do I'm going to do big F of 15 minus big F of 10 all over 15 minus 10. And I could manually plug this into the function up top, but I'm going to use my calculator. Use your calculator. Y-vars, function, 15. This gives me 85.752. That's f of 15, 85.752. Minus, I'm going to repeat that same thing, y-vars, y1 of 10. Oh, let me make sure everyone can see my button, my keystrokes here. Vars, y-vars, y1 of 10 gives me 78.164 minus 78.164 divided by, denominator should be 5. So if I subtract those, 85.752 minus 78.164 divided by 5, we get 1.5176, and I'm just going to round that, so I'm going to make that an 8. And then make sure you get units. Let's think about our units. Numerator here, cars per minute. Denominator, minutes. So I get cars per minute squared. If you really need to see that, that's cars per minute over minutes. Same thing as cars over minutes times 1 over minutes, which gets us this. So take a second, review that FRQ, make sure you know it really strong. Video has a huge advantage of you can pause, rewind, and go back and listen to a part you got stuck on. Make sure you really study this. I'll see you in FRQC.